Hello and welcome to probabilities. Here we're going to do some basic probabilities and then we're going to do these binomial distribution things. Let's get started. What is the probability of getting 4 heads in a row? Well, if you get 1, 2, 3, 4 heads in a row, the probability of the first head is 1/2, probably the second half. The second head is 1/2, third, and fourth. That's 1/2 to the fourth power. That equals 1 over 16. 1/16. Oh, good. What is the probability of getting 5 heads in a row? Well, that would just be one more of these. So that's 1/2 to the fifth power, which is 1/32. What is the probability of rolling 3 6s in a row? Now on this one it's a little bit different because we don't have a probability of 1/2 of 6. No, yeah, 6 is 6 is 6. So that's 1/6 of a chance here, 1/6 of a chance there, and 1/6 of a chance there. So this is 1/6 to the third power, or 1 over 216. Ooh, what's the probability of rolling 7 6s in a row? Well, that just keeps going out. We got 7 of them, so that's 1/6, 7 times in a row, multiplying all of them. And that gets you, oh, I need a calculator. What is 6 to the 7th power? And that is, ooh, that's a big one. 1 over 279,936. So there's your probability. Okay, what is the probability of getting a head and then rolling a 5? So getting a head, that's a 1/2 probability, and rolling a 5 is a 1/6 probability. If we times those two together, that is 1/12 of an opportunity probability of getting it. What's the probability of getting a tails and then rolling a 4? Well, that's going to be 1/2 times 1/6 again. That's 1/12. Okay, that wasn't so bad. What's the probability of not getting a 4 in 5 rolls of a die? So 1, 2, 3, 4, 5 rolls of a die and not getting a 4. So the probability of getting a 4 is 1/6. So the probability of not getting a 4 on the first roll is 5/6. On the second roll, 5/6. And the third roll, yeah. So this is the probability of not getting something is just 1 minus the probability of getting that. So we missed a 4 1, 2, 3, 4, 5 times. So that's 5/6 to the fifth power. Oh, I'm going to need that calculator again. 5 to the fifth is 3125 over, and then 6 to the fifth is 7776. There we go. That's the probability of not getting a 4 rolling the die 5 times. You could put that into a percentage. What would that be? 3125 divided by 7776. So about a 40% chance. If you were to be playing Yahtzee and you're like, hey, let's roll it. You roll 5 die. About 40% of the time you would not get a 4. Fascinating. Okay, not getting a 2 in 7 rolls of the die. So that's going to be a very similar thing. 5/6. So not getting a 2 7 times in a row. So again, that's going to be 5/6 to the 7th power. Let's go straight to a decimal on this one. 5/6 and do all that to the 7th power. Ooh, yeah, 0.27, roughly 0.27. 9. We better put one more decimal so we round appropriately. 0.279. So about 28% of the time you won't get a 2 in 7 rolls of the die. Wow, okay. What's the probability of not getting an ace in 5 draws of cards in a deck? So we draw 5 cards, kind of an interesting one. 1, 2, 3, 4, 5. Not getting an ace. So there are 4 aces. So the probability of getting an ace would be 4 out of 52. So we've got 48 out of 52 here. Now, this is where it gets kind of interesting, because the next time we draw a card, if we just drew that card out and it doesn't say that we put it back, then there are 47 cards left that are not aces, and there are only 51 cards there. And 46 out of 50, and 45 out of 49, and 44 out of 48. Yeah, the probabilities change each time. When we roll a die or we flip a coin, we kind of reset the scenario. But here, we just keep drawing these cards, so it's a little bit different. 48, 47, 46 times 45, 44. So let's do this on the calculator. 48 times 47 times 46 times 45 times 44. Okay, so this is the numerator, and then we're going to divide by, and put all this together, 52 times 51 times 50 times 49 times 48. And what does that equal? Oh, that's a 0.659, it looks like. Yeah, these probabilities, you got about a 66% chance of not drawing an ace when you pull out 5 cards. What is the probability of not getting a king in 4 draws of a card on a deck? So we're going to do the same thing, but this time it will only be right there. So 48 times 47 times those, divide by 52 times through 49, and we get 0.719. There we go. That's the probability. Okay, so those are basic probabilities. You just find the probabilities and multiply up all the conditions there. We're moving down here to a binomial distribution, and what this is the probability of getting this many, I'm going to call them wins. Like, think about a series of games where you're playing 7 games in the World Series and you got to get 4 wins, and this is the probability of it. Now, this formula can be memorized, but I think it's much easier to do this. What we just did up here with the 1 minus, like what's the probability of not getting a 4? We used 1 minus 1/6. Well, that's going to come into play here. So you'll notice this is K wins. So P is the probability of getting a win, and 1 minus P is the probability of getting a loss. So you've got this many wins and this many losses, just like what we did up here. This, however, says, oh, if you have 7 games and you've got to win 4 of them, how many different ways can you choose? Oh, notice that word. That's what we just did with counting. How many different ways can you choose 4 out of 7 wins? And then 4 wins and 3 losses. So that's kind of where this formula is built up from. So I'm going to use the terms wins and losses to describe this right here. So find the probability when we're playing 10 games, and the probability for winning each game is 0.3. So here's how we do it. Probability of winning 4 games would be, well, this is how many different ways, 10 choose 4, we can win 4 games. So we're going to win, there's 0.3, to the 4th power, so that's just like what we did up on number 1, and then we're going to lose, that's a 0.7 probability, the rest of the time, 6 times. So we better punch that guy in. So 10 choose 4, 10, remember how to do this with the choose 4, good. So there are 210 different ways we can pick this up, and we're going to times it by 0.3 to the 4th, and then we're going to times this by 0.7 to the 6th power. So we get almost exactly 0.2 for an answer there. Let's do the same thing, probability where x equals 2. So this is, we're going to have win twice. That means we're going to lose how many times? That's 8. And out of the 10 games, we've got to times that by how many different ways this scenario can happen. So there's the formula. 10 choose 2, so that's how many different ways we can win 2 games out of 10. And then here's the probability of winning 2 and the probability of losing 8. So let's plug that in. 10 choose 2. There are 45 different ways to do that, times 0.3 to the 2nd power times 0.7 to the 8th power, and we get 0.23. Let's slide out here for the next one. Probability of winning 0 games. Well, according to the formula, it's 10 choose 0. Well, this guy goes to 1. There's only one way to win 0 games, that's to lose them all. So 0.3 to the 0 power, so win 0 of them, and it's 0.7 to the 10th power. Notice that that goes to 1 and that goes to 1, so that really we're doing exactly like what we did right up here in number 7. Not getting a win in 10 games is going to be 0.7 to the 10th power. So let's plug that in the calculator, 0.7 to the 10th power. And we get, ooh, the probability of losing all 10 games is about 2.8%, 0.028. Ooh, that's a pretty small chance. Well, that makes sense. Losing every single one of them, that's pretty bad. All right, let's try the probability of winning 9 games. Probability of winning 9 games. So this is 10, choose 9. Oops, I almost did a fraction there. That would have been embarrassing. 0.3, so we're going to win 9 times and lose once. So this is the probability of winning, say, 9 straight and then losing one, but that can happen in so many different ways. So we get 10, choose 9 on the calculator. 10, choose 9, and that is 10. Yeah, there's only 10 different ways we can do that, times 0.3 to the 9th and times 0.7 to the 1st. And we get, ooh, that is so tiny. This is scientific notation, and this ends up being 0.00014. That guy has a pretty slim chance of winning 9 games right there. All right, probability of x equals 5. Let's do that one. So we get the probability that x equals 5 would be 10, choose 5, times 0.3 to the 5th power, and 0.7 then for the rest of them. So winning 5 games, losing 5 games, and let's plug that in. 10, choose 5, and that is 252 different ways. Now think about that. It's like being able to win the 1st, 2nd, 8th, 9th, 10th game, or the 1st, 2nd, 3rd, 7th, and 10th game, or something like that. There are all those different ways is counted up in the 10 choose 5. It's a great little shortcut. Times 0.3 to the 5th, that's the probability of winning those 5 games, times 0.7 to the 5th, that's the probability of losing those 5 games. So we get, about 0.10, yeah, about 10%. We'll leave it right there. That's good. Probability of winning all 10 games. Notice that this is 10 choose 10, which is going to be 1. I ought to write that out so you can see why that is. 10 factorial over 10 factorial, 0 factorial. That's what 10 choose 10 is. And 0 factorial they have defined to be 1. And then that guy cancels out with that guy. So we're 1. There's only one way to win all 10 games. And that is to have your 0.3 probability to the 10th power and your 0.7 probability, not at all. It's just 0.3 to the 10th power. That's like doing this one. What is the probability of getting probability of getting 7 6s in a row? This is just what we did. We're just doing 0.3 to the 10th power. So this equals 0.3 to the 10th power. Whoa, that's 5 zeros and then a 5 9. 0.00000059. Yeah, that's like winning the lottery. Okay, so now this one we use the exact same N and the exact same P on all of them. We're going to do these ones, and yeah, this might be a little bit tougher. Let's clear the previous work so we can see what we're doing. That's better. Okay, so number 12. What is the probability of getting 7 heads? Now notice the P is going to be, the little p is going to be 1/2 or a 0.5 when flipping the coin 12 times. So we're going to take 12 flips and pick 7 heads. A head is a win. The probability of getting a head is 1/2. So we got to get 7 of those, and we're going to lose then 5 times. These happen to be the same probability because the probability of getting a head and a tail are the same, but yeah, 12 choose 7 is how many different ways we can pick to get 7 heads. So let's plug that into the calculator. 12 choose 7 times 0.5 to the 7th and 0.5 to the 5th, that's to the 12th power. So we get a 0.193. 0.193. Good deal. Number 13. What is the probability of getting 4 6s? So now getting a 6 is what we're calling getting a win. And so we're rolling the die 5 total times. So it's going to be 5. And we're going to pick 4 different ways to get a 6. And then we get, so 5 choose 4. And then probability of getting a 6 is 1/6. So that's going to be, we're going to get 4 of those, and we have to get 1 of something else. Ooh, see what that turns out to be. 5, choose 4, times 1/6 to the 4th power times 5/6. Ooh, look at that. So getting a 4 of a kind in Yahtzee is not easy. That probability is pretty tiny. It's 0.00321. That's a pretty small probability. Yeah, rolling 5 die and getting 4 6s there, that is pretty scarce. We should write this out just a little bit so you can see where this number comes from. In order to get 4 6s, you could do 6 6 6 6 and then something that is not a 6. I'm just going to call it n. Or you could get 6 6 6 n 6, or you could get 6 6 n 6 6, or 6 n 6 6 6. This looks like a small enough group that we could actually do it. But you'll notice that each one of these has a probability of 1/6, 1/6, 1/6, 1/6, 5/6. 1/6, 1/6, 1/6, 5/6, 1/6. And so this guy, we're taking this 1/6 to the 4th and 5/6, and we're timesing it. 5 choose 4 turns out to be 1, 2, 3, 4, 5 different ways. So that's kind of a smaller example so we can see it actually all worked out. Let's go on to number 14. What's the probability of getting 4 6s when rolling the die 4 times? That's 4 choose 4. Well, that only happens one way, 6 6 6 6 6. 1/6 to the 4th and 5/6 to the 0. And the reason we have the 0 out here is we're saying we get no losses. We only have 4 options, and all 4 of them are 6s, and they all have to be wins. So let's plug that into the calculator. 1/6, and we're taking that all to the 4th power. Wow, that's pretty small. 0.00077. And we could have looked at what that is as a fraction. Just take 6 to the 4th power, and it's 1296. So this is 1 out of 1296. Okay, what's the probability of getting 4 6s, again, when rolling the die 12 times? So we're changing n a lot here. So this is going to be 12 choose 4, 1/6 to the 4th power. So we get 4 wins and 8 losses. And it happens right here. So notice we better get a higher probability, because if we roll the die 12 times, we're going to have a higher probability of getting 4 than if we only rolled it 4 times. So plug this in. 12, choose 4, enter. Now we're going to times it by 1/6 to the 4th power. Then we're going to times that by 5/6 to the 8th power. And that enters, oh yeah, 0.08. 0.08. 0.088, so 0.89 there. Okay, so notice we get almost a 10% chance when we roll the die 12 times of getting exactly 4 6s. All right, number 16. So this is the last one here. If each light bulb has a 2% chance of being burned out, so we're calling this our win, and P is going to equal 0.02. What is the probability the school with 100 lights, that's N equals 100, has 3 light bulbs that are burned out? So this is having 3 wins. So we're going to take 100, choose 3. That's how many different ways of those 100 light bulbs we could choose 3 of them to be burnt out. The probability, 0.02, of it being burnt out would be cubed, but there's a 98% chance for the other 97 light bulbs. So this is exactly what we're counting up, is how many different ways we can choose the 3 light bulbs, and for each choice we're saying, oh, we have to be burnt out or win 3 times, and then we are safe the other times. So let's plug that into the calculator, and we get 100. Choose 3. Wow, that's a lot of different ways to choose 3 light bulbs out of 100. Good thing we didn't have to do that by hand. Times 0.02 to the third power. So that's the probability of getting those 3 burnt out. And then we're timesing by 0.98, all to the 97th power. Oh, so on any given day, there is roughly a 0.182. So 18.2% chance that they would have 3 burned out light bulbs in a day. Kind of fascinating. All right, there you go for basic probability.